Bismillahirrahmanirrahim. In this video we will discuss about the speed control. This is our main power supply unit. These are the meters which are to be used in this experiment, and this is our DC machine, and this is the measuring unit. This is our main power supply unit, and this one is the rheostat, and these are the two additional meters. So now we will configure our machine. First of all, we will connect armature with the power supply. We will configure it as a separately excited machine. So 300 volt 6 ampere DC source has been connected in parallel to the armature, providing power to the armature of the machine. Then the second winding, that is the field winding, is given a supply from a separate source. So 190 volt 2 ampere supply has been used for this purpose. This can be configured as a fixed or a variable source, and you can vary the voltage with the help of the knob that we have seen. This is a separately excited machine. We are going to turn on the main power supply unit, and we will increase the voltage, and you will observe that the speed of the machine will gradually increase. But first we will set the field voltage at the maximum, because for zero field current there will be the infinite speed that you have seen in your theory class. So now we will increase the voltage with the help of this power supply unit, and you will observe that the speed will be increasing, because speed is directly proportional to the voltage that is applied to the armature. Okay, so now here is the tachometer which measures the speed of the shaft, and we have discussed its working principle in the very first slide. So now you will increase the voltage, and you will observe that the speed of the machine will be increasing with the increase of the armature voltage. It's a separately excited machine which is being fed from two different power supplies. Okay, now let's increase the voltage and observe the speed. So your first graph for this speed control of the machine will be the graph between the armature voltage and the speed. In this case, you will keep the field current constant. You will not change the field current, because the speed depends upon two factors, the field current as well as the armature voltage. The first part of the experiment is related to the armature voltage. We will be changing the voltage, armature voltage, and we will observing the speed, and then we will plot them as per instructions given in the lab manual. Okay, and in the second part, what we will do, we will keep the voltage constant, and then we will change the field current with the help of the variable resistance, or you can change it with the help of this knob of 190 volt supply, which is providing power to your field winding. Okay, now there is another way to connect this machine. So we are using measuring unit. In this case, you have observed that we have given the supply from power supply to the measuring unit, and then from measuring unit to the armature. So what is the purpose of this measuring unit? That it will measure the voltage and the current in the armature line. You can use these two meters as well with the armature. This has been set as a voltmeter, this has been set as an ammeter. You can use to measure the armature voltage or current, or you can use it with the field winding. In this case we are using with the field winding. This is an ammeter connected in series with the field winding, so supply goes to the ammeter, and then from the ammeter it goes to the field winding, and here you can observe, and then from the field winding back to your source. So now this ammeter will be in series with your field winding, because you want to measure the field current in the field winding, right? So we have connect the measuring unit for the armature, and for the field winding we are using this meter in series to measure the current. And 190 volt supply has been given to the field winding. You can control its voltage. You can set this power supply as a fixed unit or a variable unit. Now we will connect a voltmeter in parallel to the field in order to observe the field voltage, if you want to observe that one, right? So the voltmeter, here you can see the scale, it is set over the voltage, and this is measuring the voltage in parallel to your source. Now what you will be doing, you will be changing the armature voltage, and you will be observing the speed. Then you will be keeping the armature voltage constant, and you will vary the field current, and you will see the effect of variation of the field current at this speed. So first of all, what we are going to do, you can see your field current is constant, right? And you are going to change over here on this measuring unit. You have the armature parameters, armature voltage and the armature current. So we will be changing the armature voltage, and of course the armature current will be changing. And here you can see the speed corresponding to this armature voltage, that is around about 60 volts. So at 60 volt then you will increase this voltage in step, and then you will observe the speed of your series machine, which has been configured as a separately excited machine, because you are giving a separate supply to your armature and the field winding. So first part of the experiment is this one, that you will be changing the supply voltage, and then you will be observing the speed. So in this way you will record number of observations, and then using those observations you will sketch the characteristics, that is the speed variation with the armature voltage. And we have derived this expression in the theory class, that speed is directly proportional to the armature voltage, and that you are observing in this experiment. Okay, the second part of the experiment is related to the control of the speed with the help of the feedback. And what we will do for that one, for that we will either change the voltage that is applied to the field winding with the help of the control knob that is available at the supply of 190 volts 2 ampere at the power supply terminal on this terminal board, and the other way around is that we can connect a variable resistance, a rheostat in series with the field winding, and keeping the voltage constant. When we will change that rheostat, the field winding current will change, and that will change the speed of the machine. And you will observe that for the field current the relation will be inverse. That is, when you will be increasing the speed, then when you will be increasing the field current, then your speed will be decreasing, right? But in that case we will, as you know, that armature voltage and field both varies the speed. So for the first part we have kept the field current constant and we are varying the voltage, and for the second part what we will do, we will keep the armature voltage constant and we will vary the field current, so that we can study them independently, right? Okay, so you can change the current by changing the voltage at the field terminals. The first way I told you, as you can observe, we are changing the voltage, so field current is changing, and of course the speed of your machine will be changing. That you can observe over here in these meters. We are changing the field voltage, field current is changing, and the speed is changing, and that is inversely linked. Right? With the increase of the field current, your speed is decreasing. So one way is that control the voltage at the field terminal and control the current. But keep one thing in mind, that field current should not go to zero, because at that time the machine will try to get the infinite current, will try to gain the infinite speed, and that will cause the blow of the fuse in the armature circuit, because the armature current will be increasing to deliver the infinite power. Okay, so here you can see we are going to set the armature voltage at 160 volt, and now we will be changing the field current, and we will be observing the variation in the speed, right? So in this experiment you are going to study the behavior of the speed with the variation of the voltage and the field current, that is with the help of the voltage. Up to the base speed of your DC machine you use the voltage control, and above the base speed you use the field current method to control the speed. What is the base speed? The speed corresponding to the rated armature voltage. So from zero speed up to base speed, with the help of the voltage you control the speed, and when you want to go above the base speed you use the field current method. But keep one thing in mind, when you will increase the field current, the speed will decrease, and when you will decrease the field current, the speed will increase. But with the decrease of the field current, the torque induced will also decrease. So you can go above the base speed, but you will have to be careful with the load. If the machine is loaded, then the torque induced will be reduced with the decrease of the field current when you want to go above the base speed, and that may cause the vibrations and the failure of your machine. So you will have to compromise over the load. Okay, now in this screen you can see we are connecting the rheostat in series with the field winding. First we were changing the field voltage, and that was causing the change of the field current. And now what we will do, we will keep the field supply voltage constant, but we will change this rheostat that is in series with the field winding, and that will change the field current, and you will observe the effect at this speed. So this experiment can be done in a number of ways. You can vary this field voltage supply, field supply voltage, or you can connect the rheostat in series with the field winding, and you can change that rheostat and you can change the field current. So basic thing is to observe the variation in the speed with the help of these two parameters. And now you can follow the rest of the video. You can take the readings, and then with the help of the instructions given in your lab manual, you can plot the speed characteristics of the DC machine. And in this experiment, we have configured our machine as a separately excited machine. So that's all from this video. Follow it till the end and complete your lab manuals. Thank you.